Well, made the sketch. Here's what we start with. We started with the switch that I'm replacing. I got the dimensions of that. And then the switch I'm putting in, which is this reed switch. And I made a little model of the width. It's about 5 millimeters long and 2.7 wide. And then I know there's shrinkage when you print the part, so I made it a 3 by 5.5. And then I took an idea of what the layout should look like, how thick I thought I needed it. And you can see some erasures. I had it in the middle, and then I realized, wait a minute, I have the gear and the cam sitting right here, right? And they're spinning around, and this thing is flush to them. So I had to come out about 5 millimeters to get clearance, and I'm hoping that's enough. And I copied the bolt pattern here off of the other part, and then I put in the piece I needed. I cut the notch, and that's what it looks like. Okay, so don't worry about that circle. That's just a leftover thing. So that's what it's going to do. It's going to hold. I'm going to stick it down in there and move it around until it's happy, and then I'm going to fill both sides with some adhesive, some glue, and that'll hold it in place. And then it's going to come out. The lead will come out and bend back, and it'll have a female connector to it, and then it'll plug into a male connector that goes all the way to the connector to the engine. So there will be a connection in between, but this is a low energy, it's not a high powered thing. If I get a signal, I get a signal like the spark plug, right? Just give me some amps. Okay, 0.5, 0.1, 0.9, it'll work. So I'm printing now. There's the print. The printing code is running, and this is the part in what we call the slicer. You see those blue striations going across? That's a layer. So we print this out like toothpaste, and the machine goes in this pattern, X and Y, and when it fills all this pattern in, it goes boop, and it jumps up. It starts at the bottom, okay? And when it does the first one, then it jumps up, and it does the second one, then it jumps up and does it. That's how you build this part. And what we got is an estimate of 9 minutes. Over here it says 9 minutes to build this thing. And it's going to be, with the material costs, it's going to be about 2 cents. It uses so little plastic. So now I have a bracket that's going to hold the chuff sensor, which is 3 times better than the limit switch that we'd had. The limit switch cost me $3 probably. This reed switch cost me, I don't know, maybe $1, maybe not. But the bracket to adapt it cost me 2 cents in material cost. And you can say, okay, we had a printer, you got the machine. I say, okay, let's make it 20 cents. Let's make it $2. It doesn't matter. It's so. Took me 10 minutes, 2 cents. The machine is calibrating, and it's going to be printing shortly, and it will take 9 minutes to print. And I'll have the bracket, and I'll take it over. And maybe, there's an interference. I have to change something. This part sticks out too much. This part here sticks out too much, or it needs to be moved over. Hey, it doesn't matter. I'll print another one. 2 cents. You know what I mean? I'll come back, make an adjustment, and print another one. Boom. Screws are the exact same holes. I'll show you. Boom. There's the frame that we have now that we're using. Now, one difference with this frame is I've lopped off this piece here, so it's totally flush. That's why I had to make this standoff. I had originally made it flush, and then I realized, I got a newer version, so I had to do that. Not a problem. It's okay. We're good. We're gonna be okay. So I'm gonna see how that works and get back to you later. And meanwhile, everything is wired. This is the last pair of wires that need to come down toward the connectors. All the wires are I got 6 wires hanging down to the connectors. I got everything else wired. This will be the last pair to come down to go to connectors, and then I need to get real smart with my tester and verify which wire is going to be soldered to which pin. I got to do that exactly right or I'm hosed. But I'll be careful. And then I can do a test. Plug it in and turn it on low power and just make sure everything's, well, I plug it in without power and then I check continuity. I check like the sensor and then the trigger and making sure the continuity is there and it's not going somewhere else. You do those kinds of things before you power it up as much as you can. Okay, gang, that's it. I'm going back to work.